5,000 hectares of land are currently being transformed as the landscape of Southeast Asia undergoes a fundamental shift in aviation dynamics. Within this massive territory, the Long Thanh International Airport is physically manifesting through a total investment of 16 billion United States dollars. Vietnam is positioning itself as a primary driver of regional growth, where the demand for international trade and civil mobility is accelerating at a rate rarely seen in modern history. But why is such a vast scale necessary for a single aviation facility? It only looks obvious that a growing economy needs more gates, but in reality, the project is designed to handle 100 million passengers annually, placing it among the most significant infrastructure developments on the planet. Construction crews and automated machinery are currently active across the site to ensure the facility can eventually compete with the most established transit hubs in the world. The project is not a simple expansion of existing capacity. Everything only gets more complicated when considering the strategic stakes involved. One can notice how the ground is leveled to accommodate runways that will redefine the movement of global trade flows. A strategic leap of this magnitude intends to fundamentally reshape the aviation map of the entire region. The process is only gaining momentum as the state aims to secure a dominant position in the competition for Southeast Asia's transit hub status. It seems simple at first glance to build a large terminal, but this project functions as a massive economic engine designed to move the nation into a higher tier of global connectivity. The story of this mega project involves layers of logistical planning and financial commitment that extend far beyond the visible construction zones. One can notice the immense scale of the earthworks as the foundation for the future of regional transport is laid. Thus, the preliminary phase of this industrial transformation reaches its peak as the project moves toward its next critical milestone of development. 40 million passengers per year currently move through Tan Son Nhat International Airport, a facility operating at a volume that has long surpassed its original engineering specifications. Why is further expansion of this specific site physically impossible? The airport remains trapped within the dense urban fabric of Ho Chi Minh City, leaving 0 hectares for additional runways or terminal extensions. But this is just the beginning. The strain extends beyond the overcrowded halls into the high-pressure management of air traffic and the surrounding road infrastructure where transport safety is increasingly compromised. One can notice how Vietnam's tourism sector is accelerating despite these logistical constraints. International arrivals during the first quarter of 2025 rose by approximately 30% compared to the same period of the previous year. This puts the country at the forefront of growth within the Asia-Pacific region. Southeast Asian nations have entered an aggressive race to establish aviation mega-hubs to capture this regional demand. Singapore is currently expanding Changi Airport to achieve a capacity of 150 million passengers per year. Malaysia maintains Kuala Lumpur International Airport, while Thailand utilizes Suvarnabhumi Airport as its primary gateway. The Philippines is also developing Bulacan International Airport as a new transit point. It is visible how Vietnam is positioning itself to avoid falling behind in this regional competition. Long Thanh International Airport is not merely a project to relieve urban congestion. It is planned as a strategic transit hub of regional scale. 40 kilometers to the east of the current airport lies the Long Thanh area, once defined by its red basalt soil and vast rubber plantations. It seems simple to clear land, but in reality, the scale of the transformation required the relocation of approximately 4,800 households. This marked the total restructuring of the existing landscape. The process is only gaining momentum. Engineers encountered a critical challenge during the ground treatment phase due to high soil moisture levels. The natural load-bearing capacity of the basalt soil was insufficient for heavy aviation infrastructure. Hundreds of millions of cubic meters of earth were excavated, leveled, and reinforced to create a stable platform. At first glance, this looks like basic earth moving, but in reality, it required the installation of a complex underground drainage system. This ensures the structural integrity of future runways and terminal foundations. One can notice how the large-scale landfilling process generated clouds of red basalt dust that spread across several kilometers. This particulate matter threatened to impact the surrounding residential communities. To limit this dispersion, contractors implemented strict environmental controls across the site. They excavated 10 dedicated water retention ponds and deployed equipment for continuous moisture spraying. The equipment gradually stabilized the surface, suppressing the dust across the entire construction zone. These technical operations established the first physical foundation for the development of Long Thanh International Airport. The site is now prepared for the next phase of structural assembly. 5,000 hectares is the total land area allocated for the transformation of this landscape into a massive Aerotropolis. Why is the project designed as a multifunctional aviation city rather than a single terminal building? A standard airport serves only as a transit point, but this expansive territory integrates 4 passenger terminals, 4 runways measuring 4,000 meters each, and a comprehensive logistics and cargo center. This strategic layout ensures that the facility functions as a self-sustaining industrial and commercial hub. The central terminal design draws direct inspiration from the lotus flower, which serves as the national symbol of Vietnam. One can notice how the space is organized through an open structure that seamlessly incorporates multi-level transportation systems, internal parks, and decorative water features. The equipment gradually shapes the site according to a development plan divided into 3 distinct long-term phases. Phase 1 concentrates specifically on the construction of a passenger terminal spanning approximately 373,000 square meters. This structure consists of 4 functional levels, ranging from subterranean technical operations to the elevated commercial waiting lounges. It gets more complex further on. The engineering design targets the 4F standard, which represents the highest possible classification in global aviation. Because of this certification, the airport will possess the technical capability to accommodate the largest aircraft currently in operation across the globe. Total investment for this initial phase is estimated at approximately $4.6 billion United States dollars. This massive capital injection covers the terminal building, the primary runway, aircraft parking zones, and all necessary technical infrastructure. At the same time, an elevated roadway is being constructed to bridge the gap between the terminal and the external expressway network. It only looks obvious to build a simple road, but in reality, this elevated system is required to separate distinct traffic flows and prevent bottleneck congestion during peak operating hours. After the master planning phase is finalized, the focus shifts toward the takeoff and landing infrastructure, which serves as the physical operational foundation for the entire complex. Transition to the next level. One can notice that when the construction site was still occupied by rubber plantations and red basal soil, the runways existed only on paper. Before any concrete was poured, surveyors had to precisely determine the centerline axis for the primary runway. Once the boundary markers were firmly established, the entire area underwent a process where surface soil was stripped away and leveled to the exact designed elevation. This work progressed across a strip of land stretching several kilometers, requiring absolute precision to create a uniform foundation. Weak soil layers were treated, backfilled, and compacted repeatedly until the required structural stability was achieved. Therefore, the runway only began to take its final shape once the ground met these rigorous technical requirements. From a distance, the construction site transformed from rough red earth into a straight, sharply defined structure cutting through the vast landscape. The foundation is now set for the next stage of paving and system installation. One integrated network of taxiways began to take shape simultaneously with the primary runway, linking the landing strips, aircraft parking stands, and the central terminal into a single functional system. Why was the installation of the lighting system delayed until the completion of the runway surface? Precision in aviation infrastructure requires that every edge light and centerline marker sits perfectly flush with the finished pavement to ensure navigation accuracy. This meticulous alignment is followed by the simultaneous testing of signage and electronic navigation support systems to verify signal integrity before any trial operations are permitted to commence. One can notice how the lighting trial operation and calibration phase functions as a definitive boundary, marking the transition from a raw construction site to a state of operational readiness. Construction of the massive passenger terminal proceeded on a large scale in parallel with the airside infrastructure, demanding adherence to exceptionally high technical requirements. It only looks obvious to build upward, but in reality, the stability of the entire terminal depended on the completion of deep foundation works and the primary load-bearing structure. Reinforced concrete blocks gradually rose from the earth, defining each functional level of the facility through a dense grid of pillars and slabs. Thousands of workers and construction machines operated without pause to erect the structural framework and install complex mechanical and electrical systems. It is visible how the internal technical spaces were enclosed, while architectural design and structural engineering were coordinated with aviation operational requirements. This synchronization ensured that the facility could undergo commissioning without delays in the production timeline.
Everything only gets more complicated.
5,300 tons of steel are assembled to create the dome roof, which stands as the most technically complex and symbolically significant component of the entire central terminal. This multi-layer curved spatial structure covers an area of nearly 20,000 square meters and is held together through 256 critical connection points. These nodes form a massive load-bearing frame, capable of distributing enormous physical loads evenly while maintaining structural stability under high wind pressures and extreme temperature variations. At first glance, the roof is an aesthetic choice, but in reality, it serves as a technical envelope protecting the sensitive terminal environment from the elements. The curved geometry optimizes long span coverage, which significantly reduces the total number of interior columns required for support. One can notice how this architectural decision creates an uninterrupted interior space, allowing for the continuous and fluid movement of passenger traffic throughout the building. The process is only gaining momentum. Technical standards for the roof extend beyond its shape to include mandatory specifications for corrosion resistance, drainage efficiency, and long-term durability. Upon its completion, this roof becomes a technical landmark for the region, demonstrating the capacity for large-scale steel structure design and marking a significant advancement in national infrastructure engineering. Inside the terminal, the modern layout organizes check-in areas, security screening, and commercial zones into a continuous flow to minimize processing time. Intelligent operational systems are integrated directly into the technical infrastructure to manage tens of millions of passengers annually. The camera glides along the waiting lounges where every element meets international operating standards for a large-scale aviation hub. The material and structural components now stand ready to enter the final phase of service. 123 meters is the exact height the air traffic control tower rises above the vast landscape of Long Thanh Airport. This structure functions as the central brain governing every physical movement across the facility. Why is such an immense height necessary for this specific coordination center? At first glance, electronic sensors might seem sufficient for modern navigation, but in reality, the tower serves as a strategic observation point, providing a physical line of sight over the entire operational area to ensure absolute safety. The process of coordination is only gaining momentum as flights arrive and depart. The tower shaft is designed to be slender yet stable, with a diameter of approximately 10 meters. At the summit, the control cabin covers nearly 150 square meters and houses advanced display and communication systems. One can notice the specialized radar equipment installed at the very top, which enables wide-range aircraft monitoring for precise approach and landing control. With a total investment of approximately $140 million, this is the essential coordination hub where all operations are conducted accurately and continuously. 40 aircraft stands form the foundation of the expansive concrete apron directly connected to the passenger boarding bridges. 5 of these stands are dedicated to domestic aircraft, while 35 stands accommodate international flights. It only looks obvious that these are simple parking spots, but in reality, they are complex transition zones covering hundreds of thousands of square meters. It is visible how refueling, baggage handling, and pre-departure preparations are carried out simultaneously on these surfaces. The equipment moves in a synchronized manner to ensure no delays occur before each flight. Transition to the next level of the boarding process occurs through the bridges. Passenger boarding bridges at Long Thanh Airport are not merely connection devices, but critical mechanical links in the operational chain. These structures are designed to accommodate a wide range of aircraft types, including narrow-body planes for domestic routes and massive wide-body aircraft for intercontinental travel. Each bridge is a complex mechanical structure capable of rotating based on the specific parking position of the plane. It is visible how the bridge adjusts vertically to match the aircraft door height and extends precisely along the fuselage. As a result, passengers move directly between the terminal and the cabin, which reduces turnaround time and maintains a continuous operational flow. But this is just the beginning of the airport infrastructure. 8,668 meters is the total length of the perimeter fence system surrounding the entire facility. Within an airport covering 5,000 hectares, a physical boundary is essential to maintain high security standards. At first glance, the fence seems like a modest architectural element, but in reality, it integrates advanced cameras and sensors into a single access control network. The camera glides along the perimeter where this system protects technical zones, fuel storage areas, and the critical runway zones. The fence ensures the integrity of the airport boundaries while technical operations proceed inside. From here, the transformation of the landscape into a functional transport hub is complete, ensuring the material and human flow moves through a secure and controlled environment. 6,000 cubic meters is the precise volume contained within each of the 6 massive aviation fuel tanks situated at the central storage depot. Why implement such a vast underground supply model for the refueling process? At first glance, surface-level tankers might seem more direct for servicing aircraft, but in reality, an underground network eliminates the congestion of heavy ground vehicles, creating a seamless and high-capacity flow of energy across the entire facility. Fuel moves from the central tanks into a complex grid of underground pipelines that span the vast distance beneath the aircraft apron. One can notice how the equipment remains hidden from view while the pipelines terminate at specialized connection points located directly at each individual aircraft parking position. This allows for the simultaneous refueling of multiple aircraft without a single fuel truck obstructing the movement of ground crews. It gets more complex further on. Alongside these fuel lines, an extensive network of utility tunnels is strategically positioned beneath the terminal building and the apron. These subterranean corridors house the primary operational infrastructure lines, concentrating the mechanical lifeblood of the airport into a single protected environment. The process is only gaining momentum. Placing the entire technical infrastructure below the surface keeps the airside environment completely unobstructed for maneuvering. The camera glides along the smooth, clear surface of the apron where safety is maintained through the absence of physical barriers or utility hazards. This layout ensures that the daily cycle of airport operations remains stable and secure. The system functions as a concealed foundation for the complex logistical tasks occurring above. From here, the technical design allows for a continuous flow of resources that defines the modern aviation hub. Thus ends one of the key stages of the airport infrastructure overview. Tens of billions of United States dollars represent the total investment required for the completion of all phases of the Long Thanh project. Why invest such a massive amount in a mega airport when global aviation recently faced a severe crisis? The decline in air traffic during the COVID-19 pandemic triggered intense debate regarding the financial risks of this infrastructure development. But in reality, the project is structured to mitigate these risks by dividing implementation into 3 distinct phases. This allows for adjustments based on the actual pace of market recovery and fluctuations in demand. Construction activities at the site directly impact the local environment. Engineers and heavy machinery carry out large-scale land leveling across the site. One can notice how red basalt dust spreads across the horizon, covering nearby residential areas and surrounding orchards in a thin layer. It is visible how fine particles settle on every surface, leading many households in the surrounding communities to report concerns about respiratory health and daily life. It gets more complex further on. Because of these environmental challenges, specific control measures were introduced during the foundation stage. Water spraying systems operate continuously, and reservoirs have been constructed to provide a steady supply for dust suppression. Vehicle control systems regulate the movement of trucks to minimize the dispersion of red soil into the atmosphere. The process is only gaining momentum. At first glance, the environmental footprint is significant, but the airport is primarily a practical solution to the congestion in southern Vietnam. Once operational, the facility will systematically reduce pressure on Tan Son Nhut International Airport. This will improve overall operational efficiency and significantly shorten waiting times for passengers. The expansion allows for the opening of additional long-haul international routes that were previously restricted by capacity limits. Everything only gets more complicated as the aviation hub grows. Technicians, engineers, and service staff will find new opportunities within this major aviation hub. The establishment of the site generates massive demand for aircraft maintenance, technical services, and aviation workforce training. This stimulates investment in Dong Nai province and the neighboring regions, encompassing hospitality, transportation, and diverse commercial activities. Transition to the next level. The significance of the project lies in the creation of infrastructure capable of supporting long-term economic growth. If the airport reaches its full operational scale in the future, it will expand the economic development space for the entire southern region beyond simple passenger numbers. From the red basalt ground of 2020 to the current modern mega construction site, the landscape is gradually transforming. One can notice how every steel beam is installed with precision, and every meter of runway is completed according to international standards. The project is now a symbol of the country's readiness to invest in infrastructure on a global scale. Challenges regarding the construction schedule, total costs, and regional competition remain present. However, the progress on the ground confirms that the transformation into a global logistics node is moving forward. The material and structural foundations are now in place for the next phase of development.